Good evening, everyone, and thank you for being here for the inaugural episode of Robotics Live. With me tonight is Dr. John Charles Thomas. Dr. Thomas is a former IBM researcher, helped found the field of human-computer interaction, eventually left IBM to run the artificial intelligence lab at 9X Science and Technology for about a dozen years. You then returned to IBM to do some additional research in areas of knowledge management, the business use of stories, and cognitive computing. Now that sounds quite impressive and a little overwhelming. Maybe you can put it in your own words for us.
Well, I think that's a pretty good background. You know, I've been interested in psychology ever since I was a little kid, and in starting with visual illusions. So I've always been interested in how the human mind works, and I've also been interested in math. And so when I went to graduate school, I decided to go into a program that really tried to understand human behavior by making simulation models on a computer.
Okay.
Of course, at that time, the computers were not nearly as powerful as they are today. But this little iPhone now has more compute power than, was in the world when I started in graduate school.
Right. In fact, you mentioned on your Amazon that when the computer where you programmed to run experiments at Harvard had from 4 to 8K of memory. Is that right?
Yeah. We had a computer that ran the experiments and analyzed the data, and at one point it upgraded from 4K to 8K, and I thought, wow, now I can program anything.
and how far we've come, huh?
Right.
Yeah. And tell me, so your BA and your PhD are both in psychology.
Right.
How did you go from psychology to human-computer interaction?
Well, the first job I had, well, as I mentioned, I studied psychology from the perspective of computer-human interaction, and trying to understand. In fact, my dissertation was actually a comparison of one of the early AI systems called the General Problem Solver with how people solve the same problem. And although both people and the computer could solve it, they did it in quite different ways. Okay. My first job, which you mentioned at Harvard Medical School, I ran the computer system, so I learned more about that. And then when a job opened up at IBM Research, that seemed like a nice fit. And of course, I was surrounded by computer scientists, much more so than psychologists.
Yeah, and what was that like? That experience. Now, am I choppy for you?
No.
No feedback? Okay, must just be hearing it on my end.
Okay.
What was it like being around computer scientists coming from the psychology background, even though you had a background for human-computer interaction?
Well, it was interesting. I think I was probably about the fourth psychologist hired at IBM Research. One day, shortly after I joined, I heard a physicist out in the hallway who was one of these really world-famous physicists with lots of, patents and so forth. And physics, of course, is supposed to be a very hard science and rely on numbers and so on. And one of the younger colleagues of this physicist came up to the guy all excited, and he said, "Oh my gosh, I got these results. You've got to see this. It's 6.23 times 10 to the 23rd or whatever." And the guy said, "Really? Is that really what you got? That seems kind of unbelievable." And he said, "Oh yeah, that's correct within 3 orders of magnitude, one way or the other." So I thought, well, I can handle that kind of precision in psychology.
Yeah, and coming into psychology is often considered a soft science, and maybe not the most precise when it's talking about the human mind, right?
Yeah. I think part of why people feel that way about psychology is that it's hard to predict certain things, but some things are hard to predict for physicists too. If I go up in an airplane at 20,000 feet and drop a leaf, the laws of physics are known, but you're not going to know exactly where that leaf ends up.
Right.
And what people would really like to know about psychology is like, which one of these two people is going to be successful 20 years from now?
Right.
You know?
And and you can't predict that.
No, not without a complete model of the entire universe and what's going to impact them and who they're going to run into and so forth.
Sure. So maybe to simplify, and you're really helping me through, as you know, I've done some legal tech interviews, and I've done some expert witness interviews and many of those things, but maybe you can guide me here a little bit in robotics. What do we need to know about robotics that we don't currently know, or from a very early on standpoint for this new show on robotics, what is robotics and what are artificial intelligence? Maybe you can tell us that in a fairly simple manner for the layperson.
Well, yeah, I mean, the idea of a robot has been around for a while, and of course, it's popular in science fiction. One thing to note about how humans perceive the world is that we project human emotions and feelings and thought processes onto many, many things. You know, if you look at a person's face, you don't often see clouds or trees in it. But on the other hand, if you look at clouds or trees in the evening, you often see a human face.
Uh-huh.
And even toward the beginning of the last century, some psychologists studied very simple objects, you know, and you watch a square run into another square, and if it hits immediately, you think it's a physical thing. But if it sort of does this and then moves away, you tend to perceive it as beings with conscious intention and motivation and goals and so forth.
Okay.
Anyway, so artificial intelligence would be doing something that we would consider intelligent if a person did it.
Okay.
And there was a test that was suggested by a guy, Alan Turing, who was one of the founders of computer science and arguably helped win the war for the Allies, you know, by decoding the German secret code and so forth. And in his test, you would have a person communicate with either a computer or a person over a teletype. And if you, the person, couldn't tell the difference, then we would say it's passed the Turing test. In other words, it is intelligent.
Okay.
I don't totally agree with that because, as I said, people are very prone to see intelligence where it doesn't actually exist. We tend to project that onto things that are even just mechanical.
And would that, and you say that, would that be like the tweet bot that Microsoft launched a few weeks ago? Where,
yeah, that's an interesting example, and brings up a whole thing about values and how do we program in a value system into a computer program, a robot, or whatever. I mean, one thing we could do is to have it try to learn from its own experiences what its value system is, but that, of course, can be fraught with a lot of difficulties.
Which is what we saw with the tweet bot.
Which is what we saw with that.
Learning from its interactions.
Example, right. There was an early AI program that was developed by one of Marvin Minsky's students. Marvin Minsky was one of the founders of artificial intelligence, if you will.
Okay.
And one of his students named Evans, his dissertation was to build a computer program that would do figures analogies, you know, so a square with a circle inside is to a circle with a square inside, as a triangle with a circle inside is to what, you know?
Okay.
And this was multiple choice, 5 multiple choice answers. And so this guy Evans worked on this for a while, and his program was actually so powerful that it would always find an analogy between A is to B as C is to any of the answers. So in some sense, they're all correct, right?
Right. And
half of the work of his dissertation was actually in inferring what the value system was of the people that made up the test, so that the computer program would pick the, quote, correct answer.
Okay.
So, for example, if you took an L and, you reversed it, you could get to that by either rotating it in the plane or through the plane.
Right.
And the people that made up the test decided, for whatever reason, that it was more elegant or a better answer to rotate that in the plane of the paper rather than through the plane. And so that was one of the values that he had to encode into that computer program in order to get the same answers that a person would.
Okay. Okay.
Similarly, if you say 1, 2, 3, 4, what's the next number? Well, most people would say 5, but you could write a mathematical formula to get any answer you want,
Right, right.
Some are just more elegant than others.
Sure. Okay. All right. And so that, if I can, it's not really a switch, and I'm going to do full disclosure here. John was kind enough to come on for the first episode, and he provided me a list of questions in an effort to help me out in an area where I am, for the most part, brand new. Tell me about 9X. What did you guys work on? What did you work on there, and what did 9X work on?
Well, that was a great opportunity because 9X was one of the so-called baby bells and spun off from AT&T, and so we started that science and technology from scratch. And I started the artificial intelligence lab. And initially I put a lot of emphasis on expert systems. These are systems where you go and interview experts and find out the rules that they use in order to make decisions, and then you code those rules into a computer system, and it handles those cases. Then we also did work in speech recognition and synthesis. We did work in machine vision, doing character recognition, really hand-printed character recognition. Of course, machine vision has gotten much more powerful now than it was back then.
Right.
And we did work in human-computer interaction and so-called intelligent tutoring systems.
Okay.
Computer programs that try to understand from the pattern of the student's behavior what it is they understand and what they don't understand, and then provide additional examples so their learning is more effective. These intelligent tutoring systems are not as good as a really good human tutor, but they're at least they've been shown for programming in Lisp and for geometry to be much better than the typical public school education process.
Interesting. So if I'm taking a test and I take 20 different questions and I do well on most of them, but let's say 25% I'm struggling with, then it would give me more examples of the 25% that I'm struggling with so that I can continue to work on that. Is that a simple way of explaining that intelligent tutor?
Yeah, in some cases it can do a little bit more than that. It can look at the pattern of your wrong answers and figure out that you must have some particular belief that isn't quite right, or some process that you're not doing right. Like maybe if it's a simple arithmetic thing, you don't actually remember to carry from one column to the other. That would be one kind of mistake.
Okay. Okay, so yeah, so it could actually even drill down even further to see which mistakes I'm commonly making. Interesting. Okay. And naturally, we wanted to get to some of the fun sort of, a lot of people are interested in the sci-fi aspect of human-computer interaction and so forth. And I want to get to the singularity and will robots take over the world, but one of the things that interested me in this topic was the robotic and artificial intelligence impact on jobs in our economy as it currently exists. And what do you see where it's at currently, and where do we see that's going to happen? What impact are they going to have, both robots and or artificial intelligence, on our economy and on our jobs in the next, say, 5 and 10 years?
Well, that's a really good question, and I don't think there's a predetermined answer. I don't think that robots or artificial intelligence in and of themselves are going to either create more jobs or create fewer jobs. I think it's going to depend on how society decides to react with that whole thing. You know, how much training we're going to provide people. And see, I think one of the real dangers with automation systems, not even necessarily artificial intelligence systems, but you've probably experienced it yourself. You get on the phone to some help desk, or you try to contact some government agency, and you go through this whole menu of different items. For example, the first thing they ask you is, well, what kind of car do you have? Do you have a green car, a convertible,
right,
or a sedan? You know, and if you want to hear the menu over, you press 9.
right.
Well, the answer you really want isn't there. So the problem isn't in the technology so much as in the hubris of the people that designed it to think that they understood all of the options. And you almost always in human-computer interaction want to have some way of getting to a human operator or putting in a comment that's free form, not just imagine that somebody ahead of time has figured out every single contingency.
Right. Interesting.
And yeah, that's a real issue in simple tech, but it's really in spades when it comes to possible applications of robotics and cars and so forth. My wife and I actually started to write a book called Cars That Lock Too Much. And this was even before the idea of driverless cars. We had a car in Hawaii, and we pulled up to this curb where we're not actually supposed to park anyway. And we're trying to put our stuff in the car, and the policeman's there, and he says, you got to move along. And I'm like, okay, it'll just take a second. She just has to put stuff in. Well, she goes to unlock the door, and it's locked. I mean, it had been unlocked a few seconds ago, but then, so I unlock it, and then we move a little bit and try to get the luggage in, and it locks again, I mean, the people that invented that algorithm didn't foresee this kind of case.
Right. Okay. So in that same line of with the interaction between our AI and robotics, what I've seen, like the first thing that grabbed my attention about the impact on the economy was, I had that initial, they're going to wipe out all the jobs that can be automated. And that was when I first started reading into this subject, and I've come away from that. But what I thought was a very interesting aspect of both the AI and the robotics is the idea of co-botting, where it would be the robots or the AI working in conjunction with the humans. And that seems to be happening already in many respects, correct?
Yeah. And again, people have shown that humans tend to react to robots even when they have a little bit of capability and, some degree of mobility and emotion and so forth. People tend to react to them as other people. And even the brain scans show that people are empathic with the robots, and that's true of even little kids. They've done some research to show that if something bad happens to a robot, or what we would feel is bad if we were the robot, if that happens to a robot, little kids are upset
so
about it.
They are actually gaining an attachment as though it is another being in certain respects. Okay.
Yeah.
And I can go on about this all night. I feel like I'm going to have you back again in the future, because I do want to get into the singularity talk, because it is a fascinating subject. Tell us what it means and whether or not this is something you actually see happening.
Well, the singularity refers to, I think the term was first coined by Kurzweil, who was one of the people to develop reading machines for the blind. And the idea is that, okay, computers are getting faster and faster. We're also learning more about how to do certain things like pattern recognition. So the software is also improving. And there's more and more data for them to learn on. At the beginning of when I was doing speech recognition, for example, at 9X, there wasn't that much speech that was actually adequately coded for machines to learn on. And of course, it took a long time for them to learn as well. Now we have, because of everybody's, or not everybody, but there are many, many people sending lots and lots of messages. There's a lot of data for computers to train on.
Okay.
So with all of that together, there's this notion that artificial intelligence systems are going to get smarter and smarter, and they'll be able to do more and more tasks. And one of the tasks they'll be able to do is design more intelligent computing systems and program them.
Okay.
And perhaps even designing different hardware substrates for these things, as well as making better decisions about the software structure and so forth.
Okay.
So once you have a computer that's able to design a computer better than any human being can design it, then you don't have to wait for evolutionary time for us. Our intelligence, may get better and better over time, but it'll be a very slow process. Whereas with a computer, that could be done very, very quickly. And once that smart computer builds a still smarter computer, then it could really take off pretty much exponentially. That's the idea. So that's why it's called a singularity, the idea that this would just take off very, very quickly. Now, there's a couple of issues with it. One is it sort of presumes that intelligence is a unidimensional thing, and we know that it isn't. I mean, at least with people, there are many, many different sorts of intelligence. I would also say that there's a somewhat separate issue that whether or not these machines actually have intelligence or whether they are simulating, in some sense, intelligence at a high level.
Okay.
So if I built a computer program that was a very, very good simulation of a tornado, let's say,
Okay.
it might be a very useful thing. It might be able to predict when tornadoes were going to be and how, whatever, maybe eventually how to prevent them. But nobody would confuse that computer program with a tornado.
Right.
And I think when it comes to the way people think, there's an affective aspect, there's a subjective aspect, there's a consciousness aspect, and that may or may not have anything to do with, just because the computer is super smart at playing Go, let's say, to take a recent example, that doesn't mean that what goes on in that computer is anything like what goes on inside a human Go player, either emotionally or intellectually or any other way.
So it would be more strategic. It could think strategically, but not on multiple levels, maybe, in its current form.
Well, I just think that personally, I think the quality of what goes on is quite different.
Okay.
But that said, it doesn't mean that you couldn't make a computer program that would be able, you might be able to make one that's much, much better than people at programming other computers and designing other computers. So you get smarter and smarter machines. I think whether that represents a danger or not doesn't depend so much on the technology, but again, just like your earlier question about jobs, it depends on what society decides to do about it, and whether we think about these ethical and social and political issues now. People have because we can now do things like abortion and birth control and keep people alive even though their heart doesn't beat on its own and so on. These are all recent things, and people have very different and very strong feelings about what's right and wrong in those cases. Right. And I think that's certainly going to be true when it comes to things like having robots replace people for jobs. A danger I see is that the computer will only be able to deal with certain types of things, and because it can do those things more quickly and efficiently, we may tend to see that as the entire problem space. But there's really these other things at the edges that people will be able to do, but it may not be valued because it takes too long, because you have to pay people to do that. And
right.
they may get sick or go on vacation or whatever. So you'll just shrink the space to something that the computer can handle.
Okay.
And over time, we'll come to think that that's the entire problem, and it is.
Okay. All right. And you brought up a good point about the legal and the moral and the ethical. And I don't know if this is something you're aware of or not, or if it's an area part of your expertise, but are people having these conversations? Is our government having these conversations, or are medical boards or anybody like that having these conversations about what the moral, ethical, and legal ramifications are to human-computer interaction, or to robot human interaction, AI human interaction? Has it become? I'm imagining professors are having these discussions, but has it come to a point where leaders and those who govern are actually discussing these issues?
To some degree, yes. People are thinking about that. I know you have a background as a lawyer. In this book, that I wrote, the Turing's Nightmares. There are actually a couple chapters that delve into legal issues.
Okay, cool.
Yeah, you might enjoy that. There's a chapter, for example, in which, rather than execute somebody, this was sort of on the punishment side, they put him in a maze and give him one last chance to change his behavior. Because like an intelligent tutoring system, the idea is that this very intelligent system knows how this person is thinking, and they're blaming other people and so forth and so on. They put him in a situation where they have one last chance to sort of change the way they do things, and in the story they don't change. So that's it.
Okay, but there is some discussion. It just maybe it hasn't reached a critical mass yet about the implications.
Yeah, I don't think it has at all. I sometimes give the example of things like, well, it's been well documented that the automobile, for example, had huge social implications. I mean, it wasn't meant to do that. It was just meant to be a form of transportation, but it has radically altered so many things about housing and community and families and communication and so on and so forth. And even something as simple as a dishwasher, for example, which doesn't, at least in the current form, have a lot of intelligence. But when you wash dishes by hand, you have two people standing side by side. One person's usually washing, one person's rinsing, drying, or whatever. And it's an opportunity for people to communicate. And you feel like you're doing something together. So it's sort of a team effort.
Right.
When you're done, you feel like you've accomplished something together. The dishwasher is a much more solitary thing. And in fact, if two people try to load the dishwasher at the same time, it's kind of confusing and difficult. And anyway, when you're done, you just feel like you've loaded the dishwasher. You don't have the feeling of accomplishment. And it certainly doesn't, in my experience, provide the same opportunity for talking about somewhat difficult things sometimes. When you're standing face to face and looking that way, sometimes it's easier to talk about difficult topics than if you're staring right at the other person.
Yeah, that's interesting how that works. With something as simple as the dishwasher or choosing to hand wash. I have to ask a question here. Malia is a good friend of mine. She's very active in the virtual reality space. And she asks a question: since humans can develop feelings and or compassion for robots, are we programming reciprocal emotions into the robots?
Well, people are certainly exploring that in terms of, I would say, emotions as expressed. There has been some research at MIT, among other things, in having the avatar or a robot, show some kind of emotion on its face and in its actions and so forth. At a deeper level, I'm not so sure that people really have gotten into that much. I
Okay.
mean, I have struggled with what is the advantage of having emotions for a human, and would there be advantages for something similar to that in robots or artificial intelligence systems? And I think there would be, but a robot wouldn't necessarily, for its own purposes. I mean, to communicate with a human, it would be nice if it at least understood human emotions.
Mm-hmm.
But in terms of its own tasks, it may have different states that would be quite different from human emotional states. It might have 50 emotions, and none of them would be anger or fear.
Interesting. Yeah, that's fascinating. And I am going to steal one more question from you, because you provided such a great list for me to now start developing my knowledge on robotics and artificial intelligence and human-computer interactions. But what dangers do you see that maybe, everybody that I know is, when there's a new story about robotics, you get that whole Terminator 2 Judgment Day kind of Skynet kind of talk, and a lot of it's in jest. But what do you see as the actual dangers of robotics and AI, say, in the next 5 to 10 years?
Well, personally, I think of computers generally, and including different software tools as being kind of interesting tools of thought for people to actually amplify their own abilities. And so it's a very strong amplification of what people can do. So I fundamentally believe, I could be wrong, that people are more good than the bad on balance. And so I have, despite the fact that I called it Turing's nightmares, I do have a generally positive outlook about how these things are going to work out. But it's not necessarily a given. I mean, it can be an amplifier for people to communicate and understand each other's perspectives. You could imagine a more intelligent debate, more informed political debate, for example. But you can also imagine that it's an amplifier for greed, right? Or, I mean, when Minitel came out, and that was a French early version of something that allowed people to communicate by these special terminals over network. And the idea of the French government was that this would enable people to find out about services and do education and so forth. And as you might guess, the primary use of these was for pornography, which I'm not saying is necessarily bad.
Right, but you can see
that's just how it worked out. And it's not clear how artificial intelligence will actually be used in these different situations. So you have, for example, let's take the example of drones, right? I mean, you have drones, war drones that are capable of bombing and so forth, and putting fewer American lives at risk. But at the same time, they may kill more innocent people, and then, because we don't like to think about that, then there's kind of cover-ups and ways of phrasing that to make it less
ugly,
less ugly. Yeah. Right. So that's not exactly it's not a problem with the technology of machine vision. It's just kind of a reflection of other things that aren't necessarily so cool. I mean, you could also imagine artificial intelligence systems that would be very good mediators, for example. Maybe they're, in the same way that I gave a simple example about artificial intelligence tutoring systems helping people figure out what their math skills and deficiencies are, you could imagine that people from different cultures or people with different assumptions could be understood and mediated by a computer program that would help them come to resolution of issues, rather than using artificial intelligence as a weapon for one person to overcome another person more effectively.
Interesting.
I mean, that's my hope anyway.
So you don't see any major dangers then in the next 5 and 10 years? Anything that would be tremendously worrisome?
Not in that time frame with artificial intelligence. Other than what I already said, which is that we've already done things where we have an actual problem, and in order to simplify it, we reduce the problem space, and that continues to go on. That's kind of like, because of greed and trying to get things done quickly, and you've got to have a new operating system out every couple months, and so on. So those trends will continue, and since artificial intelligence is potentially a stronger amplifier than traditional programming, then whatever deficiencies are there are going to be even more prevalent and potentially more problematic.
Excellent, interesting. And Malia, I think this would be a good question for us to kind of wrap it up on tonight. I'd love for you to come back as my knowledge develops, and I can talk about it in even more, more than a lay person that I'm starting out with now. But Malia asked, are we able to, I think this is a nice light note to maybe wrap it up in, are we able to program humor into robots? Have we, or self-deprecation of any sort, or into artificial intelligence, the series and so forth? Are we able to do humor or self-deprecation, anything like that?
Well, yeah, I don't see any reason why that, in the same way that you can have a computer program learn patterns of things and differentiate bunny rabbits, let's say, from trees and so forth. I think by being exposed to enough jokes, it could start to see that. And the good thing about humor is that even if the AI system fails, it'll also be funny, right? Because it'll be funny in the way it fails.
That's right. That's right.
There was a great, I don't know if you ever watched Star Trek, and they had this Data guy on I guess it was the Next Generation or something, and he wanted to get a sense of humor, and he went around trying to tell jokes, and it took him a while to really
learn it.
And even as people don't always think that somebody else's sense of humor really is appropriate or funny or whatever, I'm sure that that'll happen with the robots too. But there's already, I mean, we have we use Siri, and we use the Echo, and there's already some specific humor programmed into it.
Oh, no kidding.
Like,
okay.
Yeah, if you ask, for example, what's the meaning of life, it'll say, like, a traditional answer is 42.
And so they are already playing with that then. And I imagine if we see Tay come back anytime soon from Microsoft, that maybe it'll be a little bit more humorous and a little less bigoted.
Yeah, that would be nice.
Yeah,
that would be nice about a lot of people.
Yeah, that's right. That's right. Robot or not. I guess, how would you wrap this up? What should somebody in my position, I imagine I'll have lay listeners, because as far as I can tell, this is the first robotics show combined with live streaming, and so I'm sure anybody who watches the replay is going to be a relatively lay person in this area. What areas should we know about? What areas should we pay attention to? And even a prediction if you want.
Well, what should you know about? Well, everybody obviously should buy a copy of my book.
Absolutely.
But apart from reading Turing's Nightmares, I guess people should start to have some conversations, with their friends and with other people about what does it mean if there is a future where 50% of the jobs, let's say, could be done more effectively and efficiently by computer. Sometimes there's pleasure in the job, and I don't presume at this point that the computer would have a job. I had a tweet the other day about something. Maybe you could replace taking care of your kids with a robot. Well, in some cases that might be important under emergency situations, but would you really want to do that on a full-time basis? No longer have to be a parent, or you could have a robot go and pet your cat. Well, would you? What's the point, right?
Right.
Yeah, you might get the cat petted. I guess from the cat's perspective, maybe it would be okay. But and then there's gardening or playing sports. Actually, one of the chapters in there is sort of a thought piece about what would it be like if you had robotic contenders. What would that mean for the participants in the sport as well as the spectators? And I don't think that Go, for example, people are going to stop playing Go, or people are going to stop tuning into Jeopardy or stop playing chess just because some computer program is better at those things than people are.
Right.
Now, when it comes to jobs, it's a little bit trickier, right? Because the people that want to make the maximum amount of money in the smallest amount of time may decide that it's more efficient and more profitable to replace the human beings with robots. And sometimes it's a false economy, really, because, as I said, they really make the problem smaller than it really is in order so that it can be done by computer.
And there would be some inherent drawbacks in that, right? If you eliminated enough jobs, then you would have fewer people with incomes to then purchase the product that you're trying to sell.
Yeah, exactly.
Interesting. And tell us, Malia had asked one last question, and tell us about Turing's Nightmares, the multiple scenario, Turing's Nightmares. Tell me about your book. I should have asked about that. I didn't realize. Was it just recently published?
Yeah. I actually, there's a lot of artwork in this book too. You can see on the cover, the book cover is actually started with a tree in our garden, and then an artificial intelligence program called Dream Deeply was applied to it. There's actually art in here from many generations. My grandfather was an artist as well as an engineer, and so there's a painting in there by him, and there's photographs by me, and my son's in the IT industry and also an artist, and then I have a grandson who's also an engineer and also an artist. So I incorporated a lot of artwork in there. The scenarios are supposed to not give definitive answers, but to be thought-provoking about particular ways that things might happen. One of these takes place in a lawyer's office. You might enjoy that. And there's a fairly lengthy chapter about a trial in the future, which has some of the trappings of trials today, but there isn't a notion of absolute guilt or innocence. It's more like trying to apportion responsibility very, very precisely based on a computer program. So that's kind of the premise of that.
Excellent.
There's also an issue raised. I mean, each one of these chapters raises a different issue, and they're somewhat independent. There's some overlap of characters. There's also a lot of Easter eggs for people that are interested in computer science. I don't know if you're familiar with that term, but sometimes a computer programmer puts like a little secret message inside the program, and if you get to this particular place, you can find this sort of hidden treasure.
Okay. Yeah, I didn't know that they had called it Easter eggs. Of course, I've heard about some of the famous ones over time, where if you negotiate. Mostly in video games is where I had heard about.
Yeah, yeah, exactly. Yeah, right. Another one raises the issue of who owns your image. You know, I mean, now you could take your image right there. I could click on that. I could build a model of you and produce a video that would, you know, have you doing various things, and people might look at that and think it's real. It might not be.
Right.
There's some interesting aspects of that. I think that's
and that just brings into the copyright and trademark infringement areas. Are the law will probably still be the same, but how images and your identity are applied are going to be changing.
Yeah, and people can now, you know, you can model somebody's voice as well.
Yeah,
and make things that you didn't actually say.
That's right. Oh, interesting point. That's an incredibly interesting point with a political campaign going on, right? You can see that instantly coming in an election season.
Right. And you do see these funny sort of things where people take little snippets of audio and then put other words in the background, right? To make it about that person or whatever.
Right.
That's kind of a new genre of humor that you can do now. In terms of virtual reality, right, we have these sort of avatars, but you can also imagine, it's probably feasible now. I don't know if it's economically feasible, but I think it's technologically feasible to take your friends and put them as avatars in a video game. You know?
Like kind of like a Second Life, only much more sophisticated.
Right. Much like Second Life. Right.
Interesting. Well, Dr. John Charles Thomas has been my guest tonight. Thank you, Dr. Thomas, for agreeing to come on here. Thank you for telling
Well, thanks for having me on. This has really been fun. And I've been looking at some of the comments on the side.
It takes some getting used to. It takes some getting used to.
There are really some good comments there, too.
Yeah, and I'd like when I'm have brought myself more up to a greater knowledge base, probably by reading your book, amongst others. I'd like to have you come back on in a few months, and maybe we'll have some more interesting things to talk about.
Sure, that'd be cool.
That'd be great. All right, and with that, I'm Nick Rishwain. Joining me tonight was Dr. John Charles Thomas. Tell us where people can find you, Dr. Thomas.
Where can you find me? Well, we could get together on LinkedIn. You could write me email at truthtable@aol.com. You have to be careful with Truth Table because for some reason, many systems want to change it to Dooth Table, which has no meaning whatever. But anyway.
And they can also connect with you on Twitter at, is it at Truth Table JCT on Twitter?
Yes.
Excellent. So you can follow him there, and there are links on Twitter at Truth Table JCT. You can find links to his Amazon books, several books, and the most recent one, Turing's Nightmares, excuse me.
Yeah, there's more than one.
More than one. And with that, thank you everybody for being here for the inaugural episode of Robotics Live.